In this video, I'm going to show you how to solve linear equations. If we're meeting for the first time, I'm Alister and my passion is teaching. On this channel, we usually have content about English, languages, or accents. However, quite a few people have been asking me to do a maths video. After all, I did teach maths for 8 years before I started teaching both maths and English. In my opinion, the best way to teach maths is through something called misconceptions. Misconceptions. So what are they? Misconceptions. A misconception is an idea that is wrong as it has been based on a failure to understand a situation. In my experience of teaching maths, I often find that people who don't understand the subject or understand what they're being asked to do have great difficulty. So I think when you're teaching maths or when you're learning maths, it is essential that you understand the ideas and the concepts that you're studying. So today we're going to look at some misconceptions about algebra and misconceptions about linear equations. So the first thing we need to ask ourselves is, what are linear equations? What are linear equations? I've often said that maths is a language, and if you understand the language, then you're much better equipped to be able to solve maths problems. So much like some of the other content on this channel, where we look at English and other languages, I believe that maths is a language. So what are linear equations? Here are 3 examples. 11 subtract 3x equals 4. 7y plus 9 equals 18. Subtract y. 14 equals 2q. So the question is, what makes these linear equations? And there's a few things. These are linear equations with one variable. And in the linear equation, the variable is the letter. So we have x, only one letter, in the first linear equation, y in the second linear equation, and q in the third linear equation. Now you can have linear equations with more than one variable, but today, in this video, we're looking at linear equations with one variable. A linear equation also has an equal sign, extremely important. And then something else that is important is that the highest power in a linear equation is 1. I'll just switch these to European ones. So we have x, imagine there's a little 1 here, y and y, imagine there's a little 1, q, imagine there's a little 1. Now if we were to change these equations to say look like something like this, where the highest power is suddenly 2, these would be called quadratic equations. If we were to change the highest power to 3, then they would be called cubic equations. And we could go on to the power of 4, to the power of 5, to the power of 6, and so on. So our linear equation has the highest power of 1. And it's the convention in maths that we don't write the little 1. A reminder that if you have something like this, x with this little 2, we would call that x squared. So you have y with a little 3, that would be y cubed. And that means y multiplied by y multiplied by y. So a total of 3 times. So that's one of the things that people find very difficult about linear equations. They don't actually know the language that is used when you're studying linear equations. Okay, next let's think about what an equation actually is. And this applies for any type of equation. And we're going to look at these 3 things in algebra, discuss what they're called, and discuss how they are different. 4z subtract 1.5, 8k plus 7k equals 15k, and 10 equals 7 plus f. So how are these three things different? When I'm teaching math, I often find that learners do not understand the difference between what is happening here. So for example, in the first one here, there's no equal sign. In the second one, there is two equal signs. So what's the difference? What's going on here? One of these is an equation. One of these we call an identity. And one of these, running out of space, we call an expression. So which is which? One is an equation, one is an expression, and one is an identity. Let's look at the expression first, which is this one. Expressions do not have equal signs. 4z subtract 1.5. What this means in very simple language is we have 4 lots of z, 4 multiplied by any number z, subtract 1.5. The second one we call an identity. 8 lots of k plus 7 lots of k equals 15 lots of k. And this third one we call an equation. 10 equals 7 plus f. So what exactly is the difference between an identity, an equation, and expression? In an expression, z can be anything. This is, in simple terms, just saying 4 lots of something, any number, subtract 1.5. This identity is very interesting. This is saying that 8 lots of something and 7 lots of something is 15 lots of something. This is just true. Sometimes in maths, we'd use a little equal sign with this 3 identity. It makes sense. 8 lots of something and 7 lots of something are 15 lots of something. Now this one is slightly different because here, as you can see very simply, f must be 3 because 7 plus 3 equals 10. So an equation, in this example, this is actually a linear equation, has one answer or one solution, is the word we usually use in maths. So in an expression, the value can be anything. In an identity, it's just saying that the two sides of the equal sign are equal. It's something that's always true. However, in an equation, there is a specific answer. And in a linear equation, the ones we're looking at today, there will always be one answer and one answer only. So when you're looking at algebra, think about what's the question, what are the possibilities? Am I dealing with an expression, an identity, or a solution? Okay, next, again, this is helping us with our misconceptions. Let's start to build up equations. So before you solve equations, it's very important that you understand the idea of balancing. So if you imagine a balance, two things are equal in weight. For them to remain balanced, if you put one on one side, a weight on one side, you must put the same weight on the other side. And that's exactly how equations work. So we're going to start like this. X equals 6. It's a very simple equation. Often it would be the last stage if you're solving an equation. Now we're going to multiply each side by 3. And it's essential that you do the same to both sides. So we have 3 lots of x equal 18. Okay, next we're going to add 4 lots of x. Again, you must preserve equality, you must remain balanced, so we'll do the same on both sides. We have 7x equals 18 plus 4x. And we'll do one more stage. We'll add 6. 7x plus 6. Remember, 7x plus 6 does not equal 13x. X, 7x, and 6 need to be separate. Equals 24 plus 4x. So ladies and gentlemen, if you understand this process of you're doing the same to both sides, when you actually come to solve equations, linear equations in this video, it becomes much easier. I draw your attention to this. At all stages, x equals 6. 3 lots of 6 equals 18. 7 lots of 6 are 42. 4 lots of 6 are 24. 24 and 18 equals 42. Still correct. 4 lots of x, 24. 24 and 24, 48. 7 lots of 6, 42. plus 6 is 48. So when you're building up equations like this, it's very good and very important to check at all stages that equality is still preserved. Okay, let's do one more example of balancing or building up equations. And we'll start with a equals 0.5. Okay, let's multiply both sides. Got to preserve equality by 4. So 4 lots of a equals 2. Then we can add 3a. 7a equals 2 plus 3a. One more step, we'll add 18. 18 plus 7a equals 20 plus 3a. Now another thing I'll say is if you switch the order, it doesn't matter. This could equally be 7a plus 18 equals 3a plus 20. It's just exactly the same, and that's important if you have balance. If you have two things that weigh the same, it doesn't matter which order you have them in. If they're on the same side, equality is preserved. Now to solve these equations, which is what we're about to do, you just do the opposite. So rather than add 18, we would subtract 18. And you would get the previous stage. So we go from 18 plus 7a equals 20 plus 3a, subtract 18, to get 7a equals 2 plus 3a. Then continuing to do the opposite, the inverse, the opposite of adding 3a is subtracting 3a. We go from 7a to 4a, and from 2 plus 3a to 2. And then the final stage, and this is often the final stage when solving equations, we would divide by 4, the opposite of multiplying by 4. 4a divided by 4 is a, and 2 divided by 4 is 2 over 4, which is a half. It's okay to leave as a decimal or a fraction. Both are acceptable. So it's very important that you understand when solving equations that it's essential to preserve equality. Let's now have a look at a couple of examples. Okay, first, 11q, like the letter Q today, subtract 6 equals 5q plus 12. There's many ways you can do this. My advice is to deal with the negatives. Let's switch to this side. So we'll add 6 to both sides. I'm only putting it on this side, but you must do it to both sides of the equation to preserve equality. So 11q minus 6 plus 6 becomes 11q. 5q plus 12 becomes 5q plus 18. Okay, next we can subtract 5q, which here will give us 6q equals 18. And if 6 lots of q equal 18, our final stage is to divide by 6. Q equals 18 divided by 6, which is 3. Good idea to underline your answer. Also, let's check. Q is 3. You want to substitute this back into the original equation. You could substitute at any stage. Q is 3. 3 lots of 11 are 33. Subtract 6, 27. 5 lots of 3 are 15. Plus 12 is 27. We'll just give ourselves a double tick. Okay, did you get the answer? Was Q equals 3? You can check at any stage. You could change the order. We didn't have to start by adding 6. We could have subtracted 12. We could have subtracted 5q. There's lots of ways of doing this. Okay, let's look at a second example together. 3 plus 3x equals 10, subtract x. What shall we do first? Again, I don't like the negatives, so I'm going to deal with the negative x. Remember, that's negative 1x, and add x to both sides. Over here, the 3 doesn't change. 3x becomes 4x. 10 doesn't change, and minus x plus x is nothing. Okay, next we've got numbers on both sides, so we're going to have to subtract 3. Usually a good idea to subtract or add the smallest number. This disappears, So we're left with 4x. 10 take away 3 is 7. Now, no number in the 4 times tables gives us the 7, so some students can find this a bit confusing. The idea is exactly the same. 4 lots of something is 7. You want to divide by 4, and we're left with x equals 7 over 4. And that answer is acceptable as a fraction, or you might want to put it as 1.75. Both are good. And remember, let's check in our original equation. Here, decimals may be easier. 10 subtract 1.75 equals 8.25. 3 plus 3 lots of 1.75, a little bit harder, is 5.25, which also equals 8.25. Give it the double tick. Well done. Now, before we look at some harder examples, if you're getting value from this video, remember to smash the like button. Here are a couple of harder examples, and if you understand what's happening, they're not really any harder. If you understand the idea of balancing, there's no problem at all here. Okay, first let's try one with brackets. 4 in brackets, y minus 6 plus 3 equals negative 35, subtract 10y. A little bit more complicated. First thing we want to do here, ladies and gentlemen, is expand the brackets. Multiply out the brackets. So 4 lots of y, 4y. 4 lots of minus 6, minus 24. We'll keep the plus 3, equals minus 35, minus 10y. Now we need to simplify this. We've got minus 24 plus 3. 4y minus 21 equals minus 35 minus 10y. And now this is exactly the same as the previous ones we've done. I'm going to deal with the 10y first. I don't like a minus 10y. But there's lots of ways of doing this, and we'll add 10y to both sides. So this disappears. We have 14y, subtract 21 equals minus 35. Okay, numbers on both sides. We need to deal with this minus 21. So we can add 21 to both sides of the equation. Remember, you're preserving equality. And we have 14y equals minus 14. Remember, minus 35 plus 21 becomes minus 14. So 14 lots of y are minus 14, negative number. You want to divide by 14. And the answer would be y equals minus 1. Now, again, what you need to do is check. For the sake of time, I'm not going to check. You would substitute y equals minus 1 back in here and check that both sides of the equation are equal. Okay, let's look at one final example together, most difficult one, with fractions. And I'll say again, if you understand what a linear equation is and understand what it means to solve an equation, this is very easy. You're preserving equality on both sides. Here we go. And we'll go for x again. 5x minus 3, all divided by 2, or over 2, equals 26 minus 3x. So how do we deal with this fraction? How do we deal with this fraction here? Quite simple. This is divided by 2, so we need to multiply everything by 2. The left-hand side by 2 and the right-hand side by 2. Right-hand side's possibly easier if you're confused. 26 times 2 is 52. Minus 3x times 2 minus 6x. And then to multiply this, so imagine this is in brackets just for a moment. This is saying 5x minus 3 divided by 2. All of it divided by 2. So if you multiply it by 2, it just becomes 5x minus 3, which is quite simple. And then we're dead easy. I will add 6x. 11x minus 3 equals 52. Then I will add 3. 11x equals 55. X equals 5. I'm going to check really quickly. 5 5s is 25. Take away 3 is 22. Divided by 2 is 11. 3 5s are 15. 26. Take away 15 is 11. So we are correct. So there you have it. This is how to solve linear equations. I'm a maths tutor, by the way, and if you want further help, please drop me an email. My details are in the description below, and good luck with your learning maths.